Hello. In this video, we're going to go ahead and find the following limit. We have the limit as h goes to 0 of 5 all over 8 plus h minus 5 over 8 all over h. Now, here's the thing. To do this, we need to be able to make h become 0. But notice if we do that, the denominator here is 0, but in the numerator, we also get 0 because this is 5 over 8 minus 5 over 8, that becomes 0. So something's happening that we need to look at. So notice that there's a denominator, well, this is what we call a complex fraction. And we don't like complex fractions, so what we're going to do is we're going to look at the denominators of 8 plus h and 8 as well. And we're going to consider those to be factors. So the GCF, or the greatest common factor for all terms here, I'm considering each individual term in both the numerator and denominator, is going to be simply 8 plus h times 8. So what I'm going to do is I'm going to take, not infinity, but 0, take this, the limit as h goes to 0, of 5 over 8 plus h, and I'm going to multiply that by the GCF of 8 plus h times 8. And then, of course, then we have our minus the 5 over 8, and again, multiplied by 8 plus h times 8. All over, and in the denominator, we have the h, and then times the GCF of 8 plus h times 8. Okay, now, what did this just do for us? This makes it look a whole lot worse, doesn't it? Well, actually it doesn't. It actually makes things easier on us because if you notice, this denominator cancels with that right there, and this denominator cancels with that right there. They're all gone. So let's write down what we have left from this. This is going to give us the limit as h goes to 0 of 5 times 8 minus 5 times 8 plus h, then all over in the denominator, all that's still there. So I'm going to make this 8h times 8 plus h. Now, in the numerator, distribute that negative 5 to both the 8 and the negative, or excuse me, the 8 and the h, which gives me the limit as h goes to 0 of 5 times 8 is 40, and then minus 5 times 8 again is 40, and then minus 5 times h is negative 5h. Now be very, very careful. Right here is where you're very likely going to mess up because a lot of people forget about distributing the negative to both the 8 and the h. So a lot of people, everyone distributes the 5. Well, most people distribute the 5. A lot of people forget that negative that goes along with the 5. So just be very careful with that. And then all over the denominator of 8h times 8 plus h. Wonderful. But what's this done for us? Notice the 40 and the negative 40, that all just becomes 0 because 40 minus 40 is 0. They cancel each other. So really what we're left with here is actually the limit as h goes to 0 of negative 5h all over 8h times 8 plus h. Awesome. Now notice that we now have a common factor of h in both the numerator and denominator, so they cancel each other as well. So really this just becomes the limit as h goes to 0 of negative 5 all over 8 times 8 plus h. And that's where we needed to get to. And the reason why is because this h in the entire thing has been a problem the entire time. If I plug in h to be 0, that's 0. H becomes 0, all of this is 0. H becomes 0, all of this is 0. H becomes 0, all of this is 0. But when they cancel, notice that there is no more 0 right there. But there is still an h. There's nothing wrong with that, because now if I plug in h into this function, 8 plus 0 is 8, and 8 times 8 is 64. So that denominator is just 64. It is no longer 0, which is a very important thing for us to have. So this is simply negative 5 over 64. And then simplify that if you can. In this case, you cannot. So therefore, negative 5 over 64 is what this will become. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.